So question 5a says determine the first derivative of f from first principles. So to get the first derivative from first principles, we take the limit as h tends to 0 of f of x plus h minus f of x all over h. So first of all, we need to find what f of x plus h is. But before we do that, it would be quite tricky if we were to, let me put this here. It would be quite tricky if we tried to f of x plus h while it's in that format, because what we end up having is x plus h minus 3 squared, and then we would have a trinomial and a trinomial that we need to multiply out. So I guess what would be the easier method would be to first multiply out this x minus 3. So simplify it a bit to get x squared minus 6x plus 9. So that's x squared, and then x times minus 3 is minus 3x, times 2 is minus 6x, and then the last term is minus 3 squared, giving us 9. From this, it'd be much easier to do f of x plus h, which would be x plus h squared minus 6x plus h plus 9. Can simplify this to x squared plus 2xh plus h squared minus 6x minus 6h plus 9. So it's quite a lot, but this is what we end up with. And in the following step, we can make these substitutions. So we'll have x squared. Let's see first, are there any like terms? X squared, xh, h squared, h, x, 9. Okay, no like terms, so we just write it as is. So again, x squared plus 2xh plus h squared minus 6x minus 6h plus 9, and then minus f of x. F of x is x squared minus 6x plus 9. And then this is all over h. So now it's the time to look for things to cancel. So starting with x squared, it will be minus x squared. And then we also have minus 6x here, but it will be plus 6x, and here there's a minus 6x. So these two cancel. Then we have a positive 9 and a minus 9. So that cancels as well. And then all we are left with is this two terms over here and that other one. So in the following line, we still have the limit as h tends to 0 of 2xh plus h squared minus 6h all over h. And then what we can do is, in order for us to make the substitution for h, we need to get rid of that fraction. So how do we do that? We take h out to be left with 2x plus h minus 6 all over h. The reason we want to take this h at the bottom out is because if we make the substitution, or if we take h as it tends to 0, it will become undefined because we cannot have something over 0. So once we cancel this, then we can now take the limit as h tends to 0 for whatever is left, which is 2x plus h minus 6. And put in h as 0, you get 2x plus 6. And that is your answer. And you can also confirm this by taking the first derivative of this using the shortcut method, which will give you 2x, 2 minus 1, that will be 1, and then minus 6. So, oh yes, minus 6, I don't know how, plus 6, minus 6 over here. That's your answer.